Welcome to a new video for the Descriptive Statistics course. Here we will start another part of our chapter that the dispersion or the measures of variation. As we mentioned before, there are many methods and measures for the statistical methods and techniques. First, we take the measures of central tendency or what's called by the measures of location. Now we will start to the second part with the dispersion or the measures of variation. Then in the third part in our chapter, we will take the measures of positions. Now let's start the measures of dispersion or variation. The measures of location that we already take in the first part, such as the mean, the median, only describe the center of the data and how the data are located and where. But it is valuable from the standpoint, but it doesn't tell us how anything about the spread of the data. The spread of the data in and what is the dispersion of the data. So we want to another type that can tell us that how the data is varied from the center and what the values for the data that's far from the mean. Now we will take the measures of dispersions. The most common measures are range, mean deviation, variance, and standard deviation. For the range, it's a rule for the range that is the largest value minus the smallest value, which is the first and the simplest measures of dispersion that we take all the values and get out the largest value and subtract from it the smallest value, so we have a range. It's an indicator, but in the most situations it's very simple, but it's not get a clear picture for us for the dispersion of the data. Then another method came out that it's mean deviation, which is this rule for the mean deviation. Then we will take the variance and standard deviation, and this is the rule for it. Now we will take each item in details and more examples to get the meaning very clearly for it. The first, which is the range, is the number of the items. We have an example now. The number of items that sold at a Starbucks location in the Orange County Airport between 4 and 7 p.m. for a sample of 5 days last year were 20, 40, 50, 60, and 80. Determine the range for the number of items sold. Of course, as we mentioned in the rule that we already in the previous slide, that the range equal to the largest value minus the smallest value. The largest value here is 80 and the smallest value is 20. So the range is equal to 60, which is the difference between the largest value and the smallest value. Here, as you see, that the range is the first measure of dispersion or of variation, which is very easy to calculate, but it don't give us a clear idea about how spread is the data and far from the mean. It only get the depend on the largest and the smallest value. So this value may be vary if we have outliers. Say if we have here outliers value that is 1,000 or 100,000, so it's 10,000. So we will get by substituting direct in the rule the largest value 10,000 minus 20, so the range will be the range. But we have an outlier, so the range is not the best for the measures of dispersion. So we move to another measure, which is the mean deviation. The mean deviation is the arithmetic mean of the absolute values of deviations from the arithmetic mean. What's this mean? This means that in the first step, we should get the value of the arithmetic mean that we already take it and take the examples and exercises for it, which is the summation for all values divided by the number of all values in the two cases of the population or the sample. So we added up all the sample and divided by the number of the samples and get the arithmetic mean. Then we use this for calculating the mean deviation, where the mean deviation is a shortcoming of the range that is based only on two values. Here, we now use all the values, not only two values like the range. So we will get first the value of the mean, which is x bar, and then subtract it from each item and take the absolute value for them and added them all up and finally divided by n. So the mean deviation formula will equal to MD as noted as mentioned for mean deviation equal to summation for the absolute value of x minus x bar divided by n, where x is the value of each observation and x bar is the arithmetic mean, n is the number of all the observations in the sample. And of course, you know that the two part here means the absolute value. The mean deviation measures the mean amount in which the values in a population or sample vary from the mean. Where if we have mean here, we are x bar here, and the values here, x's here, we measure how are these values far from the mean, how each value is far from the mean. So the mean deviation is measure how the values are far from the mean. Let's take an example to know how to calculate and compute the mean deviation. The number of items sold at Starbucks location in the Orange Company Airport between 4 and 7 p.m. for a sample 5 days last year were 20, 40, 50, 60, and 80. The same example that we get it for the range, it's for compute the mean deviation. First, we should get the value for x bar, which is the arithmetic mean, equal to summation for all items sold over the total number of items, which are 5 items. So add them up all, 20 plus 40 plus 50 plus 60 plus 80, and divided by 5 equal to 50, which is the arithmetic mean. Then we will make a table to simplifying the calculations and subtract from each item the value that we get it in the arithmetic mean, which is for the first day 20 minus 50 equal negative 30 by its value, by its a sign, negative 30. Here 40 minus 50 equal to minus 10 or negative 10. 54 is the third day, 50 minus 50 equal to here equal to 0. Then the third day, fourth day, 60 minus 50, which is the arithmetic mean, equal to 10. Then the fifth day equal to 80 minus 50, which is the arithmetic mean, equal to 30. So all the value we subtract the mean that we get it in the first step from it to get the values for x minus x bar. Now we will take the absolute value for these values. I have mentioned in the pure mathematics course that absolute value for negative 30 equal to 30, absolute value for negative 10 equal to 10, and the positive value of course take the same. Then adding up all the absolute values, here this column for the absolute value, x minus x bar. Then adding up all the values for the absolute values, we get it equal to 30. Sorry, we get it equal to 80. Now, let's note that if we add them before taking the absolute value, the total value will equal to 0. 30, minus 10, here positive 30, positive 10, and 0. So the summation will equal to 0. So you should first take the absolute value to get rid of the negative signs and adding them up to get it equal to 80. The final step that we substituting in the mean deviation rule, which is equal to the total summation, which is for the absolute value equal to 80 over n, which is the total sample size, equal to 60. Now it's simply to calculate the mean deviation for any group of data. Then we will move to the variance and the standard deviation. The variance is the arithmetic mean of spread deviations from the mean, and the standard deviation is the root for the variance. It's very simple because the variance rule is very near from the mean deviation rules, but we only square the difference and take summation of the square. And the standard deviation is the root for the variance. Once you get the value for the variance, you take the square root for it, and then you will have the standard deviation. Let's see what is the requirements and the advantages of the variance and the standard deviation. First, the variance and the standard deviations are non-negative and are zero only if all observations are the same. Of course, if the observations are the same, so the negative values equal to positive values, so the summation will equal to 0. Then, the populations whose values are near to the mean, the variance and standard deviations will be small. Of course, yes, because we have that their values dispersion will be small and all the values will be near the mean. So the variance value and the standard deviation will be small, and this for the homogeneous data that is all around the mean. But if the populations or those are dispersed from the mean, the variance and the standard deviation will be the large. Finally, the variance overcomes the weakness of the range, but that's because it's using all the values in the population like the mean deviation. Let's take an example. The variance formula computation equal to sigma square, which is equal to summation x minus mu all square over n, like this. Please know the samples. This sample, which is a Greek letter sigma, called sigma. Sigma is the population mean. It's the population variance, and read as sigma squared. X are the values of the value of an observation in the population, and mu is the arithmetic mean for the population, and n in the denominators is the number of observations in the population, the total number for the population. Now we are using the population variance or the rule for the population variance, not the mean. So again, the population variance called sigma square. This a Greek letter which is called sigma. So it's a sigma squared, and x is the values of the observations in the population. Mu is the arithmetic mean for the population, and capital N is the total number of the observations in the population. When we computing the variance for the population, we should first get the mean, then subtracting the value of the mean from all the observations, like the steps in the mean deviation, then squaring them up, and then sum all the values and divide it finally by total n. Let's take an example to show this. The number of traffic citizens issued during the last 5 months in the country of South California is reported below. Here, 12 months, okay, and the data is presented in this table. What is the population variance? First step, we will get the mean. When we get the mean, we add all the values because it's our population. All the months in the year equal to 12 months. So it's a population for us. Now we will add them up and divide it by the total number of months, which is equal to 12. It is equal to 29, which is the population mean. Then we will find the difference between each observation and the 29. I mean 19 minus 29, then 17 minus 29, 22 minus 29, and so on. Let's put it in the table for simplifying the calculations, like this. Now we have the values given in this column, x's, and we computing the mean and find it equal to 29 mu equal to 29. So the first x minus mu, I mean hx minus 29. Here 19 minus 29 equal to minus 10. 17 minus 29 equal to minus 12. 22 minus 29 equal to minus 7. 18 minus 29 equal to minus 11. 28 minus 29 equal to minus 1. 34 minus 29 equal to 5. 45 minus 29 equal to 16, and so on. Then we will square each value for the difference between the value and the arithmetic mean for the population. If we squaring negative 10 square equal to 100, negative 12 square equal to 144, negative 7 square equal to 49, negative 11 square equal to 121, negative 1 square equal to 1, positive 5 square equal to 25, and so on. We will squaring the difference this column. After squaring the difference, we will add all up. When we adding this column, third column up, we find the total value equal to 1488. Dividing this by the total number of the population, which is 12, to get sigma square, which is the variance of the population, equal to 124. Now, let's take the sample variance. The sample variance equal to S square, which is the sample for it, and equal to the summation of the difference between the x minus x bar all square over n minus 1. Note that the S square is the sample variance, not the population variance. The rule now differs. That's the difference only in the denominator. The calculation will take the same steps, but here we will divide over n minus 1, which is the sample size or the number of observations in the sample minus 1. But in the population variance, we divided by capital N, which is the total number of population. Okay, now again, sample variance noted as S square, and x is the value of each observation in sample, x bar is the mean of the sample, and n is the total number of observations in the sample. Let's take an example for the sample variance. The sample variance, if you have the hourly wages for a sample of part-time employees at home are $12, $20, $16, $18, and $19. What is the sample variance? The sample variance S square, as mentioned before, for its formula, will have the same steps for the population variance, except when we divide over n small minus 1. So we will get first the mean or the arithmetic mean for total values. So we will take the arithmetic mean x power for the sample mean equal to 12 plus 20 plus 16 plus 18 plus 19 over the total number, which are 5. Okay, then we will take a column for it, which is equal to 17 here. The x power will equal to 17. So subtracting 17 from each value. Now 12 minus 17 equal to negative 5. 20 minus 17 equal to 3. 16 minus 17 equal to negative 1. 18 minus 17 equal to 1. 19 minus 17 equal to 2. Then squaring each value for the difference between x and x power. Okay, we will squaring this column, the second column, we get minus 5 squared equal to 25, 3 squared equal to 9, negative 1 squared equal to 1, 1 squared 1, and finally 2 squared equal to 4. Then we will adding up all the values in the third column, we get the x minus x power all squared equal to 40, and dividing 40 over the total values in the sample minus 1, which is 5 minus 1 equal to 10. This is the value for the sample variance. Now we already take the most common measures of variation or dispersion, which are range and mean deviation, variance in the two cases, population and sample, and then the standard deviation, and the standard deviation, which is the square root for the variance. For example, here the standard deviation for in this example equal to s. Okay, s equal to the square root of s squared, which is equal to square root of 10. This is the standard deviation in this case. And in the previous example, for the standard deviation for the population case, we will take the square root for 1488. This is the standard deviation in the previous example for the population variance. Now we finished the most common methods for the measures of dispersions, or what's called measure of variation. You should practice more on this part because we will continue for the group data and the coefficient of variation in the next video. Thank you. This is the formula for the standard deviation.